So the second transformation we're going to look at, we're actually going to do the second and the third, are going to be the vertical changes. So yesterday we looked at a horizontal shift, and what was the name of that again? It's called a phase shift. Okay, that's just what they call a horizontal shift when you do it with trig. Today we're going to look at amplitude change and vertical shifts. So first of all, what's the amplitude? Well, the amplitude measures how tall the wave is. And up until now, the wave has always had a certain height to it. Does anybody remember when we drew it, what the highest that it went was? 1. And the lowest? Negative 1. So the amplitude is that distance from the center of the wave to the highest or to the lowest point. So the amplitude measures the distance. Like you, measures how tall you are. You measure how tall you are, that's the distance between where the ground and the top of your head. So it measures a distance. If amplitude measures a distance, what kind of number do you think it always has to be? Do you always have to be 6 feet tall?
Well, not 6 feet.
Right, but does somebody always have to be 6 feet? Exactly, right? You could be different heights. But no matter what your height is, every single person's height in this room is a kind of number. You could be like, 6 feet 2 inches, so now that's not a whole number. Yeah? Positive. Okay, no matter what the height is, it is positive. Same with when you're measuring the amplitude of a sine wave or a cosine wave. It is always positive. So what does an amplitude change look like? Well, when you do stuff inside here, that's horizontal. We did some stuff inside there yesterday. We added and we subtracted. Today we're talking about vertical. When you do something that's vertical, it's going to be outside these parentheses. And the first vertical transformation we're going to look at is an amplitude change. An amplitude change is when you multiply by a number in front of the function. Just like we saw with vertical stretches when we did other functions. This is a vertical stretch. The bigger you make the number in front, the bigger the stretch you get. The smaller you make the number, the more compressed it gets. And if you put a negative in front with the number, now you've got two things happening. What does a negative in front do? Yeah, it causes a reflection. And what kind of reflection does it cause? Vertical. Yeah. So if you've got a negative, it causes a vertical reflection. So what we want to be able to do without even graphing is just look at these three and tell me what the amplitude is. Here's how you figure out the amplitude without even making a sketch. The amplitude is the absolute value of A. A was the number that I had in front. Okay, so it's the absolute value of the number that's in front. Because it's absolute value, I already said that to you, the amplitude is always positive. Okay, so let's try those three examples I had up above. And see if we can figure out amplitudes. Let's start with the first one, 3 sine x. What do you think the amplitude would be for 3 sine x. Yeah?
30.
3. So what that means is this graph is no longer going to be negative 1 to 1 when you draw it. It's going to go 3 times as high and 3 times as low. Right. How about the second one? Y equals negative 2 cosine x. What do you think the amplitude is going to be there? It would be 2. Yes, the negative is going to flip it, but the negative has nothing to do with the amplitude. The negative has to do with when we sketch it. And how about this one? 1/2 sine x. Yep, amplitude there would be a half. Now, what if I did that? The amplitude's still a half. What if I did this?
Well, it'd still be half.
It'd still be half.
The diagonal's in a different box.
Yeah, this is a phase shift. We talked about this yesterday. Shifting something left or right doesn't change how high and low it goes. So you may have other things in the problem, but the absolute value is controlled by the amplitude is controlled by the number in front. So one of two things is going to happen when you put a number in front. If the number that you put in front is bigger than 1, the absolute value of it, it's going to stretch. So if we go back up, this first one is a stretch. The second one is a stretch. It's also a flip, but I didn't really care about that. Okay, so the first one and the second one are both going to cause the graph to stretch. If the absolute value is less than 1, so numbers that have an absolute value of less than 1, 0.5, 1/3, negative 0.6. All those numbers have an absolute value less than 1. That's going to compress the graph. And which way is it going to compress it? Up and down, vertically. So the only one that is a compression in this one is the third one, 1/2. And the original problem was just sine x.
You scroll down.
So you heard what a phase shift does. Okay, it's a little hard to kind of explain it, but you kind of heard it is getting louder and softer. But what about an amplitude change? If you played a sound, and let's say the sound, picture of the sound looked like that, and then you played a sound like this.
One's going to be fast.
What do you mean by fast? Like, how would you hear fast?
Well, one's going to play like at a faster pace.
So, what is a fast sound? What does it mean for like a sound? I'm not really sure what we mean.
It goes through the frequencies faster because it's like not as big.
So you think the sound is going to change? Like, it's not going to be the same tone the whole time. It's going to like change, like a voice sign or something. It's going to like go up, change like that. Okay. Any other thoughts? What could happen? Yeah.
The pitch might change.
Okay, so that's one thing that could change, the pitch. For the purpose of what we do, we're always going to be talking about a sound that stays the same once you hit play, right? We might change it before, but once we start hitting play, the pitch would stay the same the whole time. But that's one thing that could change. We could do that, hit play, and hear the black one. It might change the pitch. Or what else can change about a sound? Besides the pitch. The what?
The bass, maybe.
So if you had more bass in the sound, I think that would change the pitch. It would make it like a lower frequency. But how about something else that can change besides the pitch?
The volume.
The volume. Right. The volume. So the volume can also change. In this case, that's a volume change. The taller you make the wave, the louder the sound gets. The more compressed you make it, the softer it gets. So, let me see, I can show you that. Not as interesting as a phase shift, but let's see. So, there's your sound. And when I play it, watch the wave, and then listen to what's happening as you watch what the wave is doing. So, as I started to compress the wave, it got quiet. And I take this, stretch the wave, it gets louder. So, stretching and compressing the wave vertically changes the volume. So now let's think about a coordinate like on this wave, like at that point right at the top. As you stretch and compress it, that coordinate has two numbers. It has an x and it has a y. Which value is changing?
Y.
The y. Right? This point is basically moving up and down with every other point. They're all moving up and down. So what that means is if the y values are changing, the x's are staying the same. And it's nice when the x's stay the same because the x's are all fractions with pi. You do not have to work with any of the fractions with pi to do an amplitude change. So I can tell you the answer for the x's right now for every amplitude change we're going to do today. 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are the x's. So if the x's are going to stay the same, then it's the y's that are going to change. To find the new y values, all you have to do is take the number that's in front, which we call a, and multiply all the old y values by the number that's in front. Notice here, I didn't say anything about absolute value. You don't want to get rid of the negative if there was a negative in front, because the negative is going to cause a flip. And the only time you get rid of the negative is if the question says, what is the amplitude? Then you don't want to give me a negative. Other than that, just take the number that's in front, just the way it is, and multiply the old y values by that number. So we have to find new y values, but think about the old y values. What kind of numbers do we have in the y values? They're either sine or cosine.
0, 1, negative 1.
They're all zeros, ones, and negative ones. So this transformation, arithmetic-wise, is a lot easier than a phase shift. You don't have any common denominators. All you have to do is multiply a number by 1, 0, or negative 1. Very simple arithmetic. Let's try an example. So it says graph y equals 3 cosine x. Same idea as yesterday. Table is going to have 5 coordinates, making up 10 numbers. You get 1 point for each number, 2 points for the sketch. All right, so now 3 cosine x. First thing I want to know is that a phase shift? We studied that. Or is that an amplitude change? How do you know it's an amplitude change?
Because it's got the 3 in front of cosine.
Right. You have to look where the number is. In this case, the number is multiplication, which that's not what we studied at all yesterday. So first of all, it's multiplication. Second of all, it's in front. That makes it an amplitude change. All right. So we're going to stretch and compress it vertically. What's going to stay the same? X's. And what are my x values?
0, 5, 5, 5, 5.
Okay, I'm going to put all my final answers in that table, but off to the side, I'll put the originals and the calculation I'm going to do to get what goes in the table. What are the original y values for cosine?
1, 0, -1, 0.
Okay. And the directions say to find the new y values, multiply the old y values by the number in front. Okay. So, Kiana, what am I going to multiply the old y values by? 3. Yeah, good. So we'll multiply all the old y values by. All right. So Tony, what are my new y values going to be?
3, 0, maybe 3, 0, 3.
Yep. So those are my new y values. Okay. Questions on the table? All right. Now the sketch. Well, depending on how big you put this number in front, you potentially could have to draw your graph very big. So what we're going to do to avoid having to keep drawing it bigger and bigger and bigger is we're just going to scale these axes. So I'm going to look at the highest I need to go and the lowest, and I'll use those for my scale. So let's go by 3s on the y-axis. All right. And label your x's, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now plot your points. 3, 0, -3, 0, 3. 3, 0, -3, 0, and 3. And remember, it should look like there's a curve to it. I'm just going to shrink the screen because it's easier for me to draw the graph if it's not as big. There's your graph. Because we're scaling the y-axis, every single problem today is going to look the same. Like if I had to graph y equals 7 cosine x, I would use that exact same picture. The only thing I would do is this. 7, -7. Now you're looking at a picture of 7 cosine x. So every picture today is going to look the same for cosine. I'm going to change my scale. Any questions on that? And if you don't want to change your scale, okay, that's fine. But the problem is if I give you a really big number here like 50, well, if you really want to have to go 50 units up and 50 units down, you're going to need a grid that's 100 units. That's a lot. Okay, let's try this one. So y equals 1/2 sine x. First step, figure out what kind of transformation it is, and then think about which column stays the same. So Cameron, what kind of transformation is this one?
Compression.
Can you be a little bit more general? Or, well, what kind of compression? because there's more than one kind of compression. So I need to know something else. Can somebody else tell me what they think's going on here? Yeah, it's an amplitude change, which we always call a what? When we do other transformations. Not a shift. It's a stretch. It could be a stretch or compression. The point I was getting at is when it's in front and it's multiplication like that, it's a vertical stretch. So when we want to write down the 5 points in our first cycle, which values there are unaffected by doing a vertical stretch? The x's. Correct. So what are the x's that we always use that mark those quarter points in the first cycle?
0, pi over 2, pi.
Yep. Okay. And now off to the side, let's put the original y values for sine in that first cycle, and then we'll figure out what we got to do. How about Mr. Bath? What are my y values?
Oh,
For sine
let's see.
in that first cycle.
We have 0.
And you don't have to do the 1/2 yet. We're going to do that after.
Oh, okay. 0, 1, 0. I believe that would be -1.
And 1.
And that would be 0.
Perfect. Thank you very much. All right. And now we have to compress that by, we have to shrink it by 1/2. So what do we multiply them all by? Multiply them all by 1/2. Okay. Which is the same as dividing them by 2. All right. How about Fiorella? What are going to be my new y values?
0, 1/2, 0, -1/2, and 0.
Yep. Any questions on the table? So this one is a compression. In terms of the sound, it's going to be quiet. Right, let's make our graph. Again, I do the same thing that I did with cosine. I just scale my axes. 0, 1/2, and -1/2. Right. And here, I'm going to go 0, pi over 2, pi, 3 pi over 2, 2 pi. Yes, you do need to label those x values, because if you don't, what do we always assume you're going by if you don't put labels?
Radius.
Well, not the unit, the increment. The increment is always a 1 if you don't put labels. So put labels, because we're not going by ones. Okay, so 0, 1/2, 0, -1/2, 0. 0, 1/2, 0, -1/2, 0. And there's your sketch. And if you had to sketch another cycle, all you do is copy and paste that to the next cycle. Because this is periodic, which means the pattern repeats. Okay, any questions on that? Okay. Now, this one is, it does fall in the same category of stuff that we're doing right now, but it's a little bit different. What number is in front of here? If you had to put a number there, because there isn't really a number right now.
-1.
Right, it's like having a -1. So the question is -1 going to change the amplitude? No. What is the -1 going to do? It's just going to reflect it. So technically there is no change in the amplitude, but we still figure out the table the same way. So, make our table. Okay, we already did cosine earlier, so hopefully we remember what the x's were. 0 to 2 pi. So let's put those. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And let's put the original y values off to the side. 1. What are my original y values for cosine?
Zero, zero.
And now we're going to multiply all those y values by something to get new ones. Jenna, what do we multiply them all by?
-1.
-1. So I'm just going to plug times -1. I just use parentheses because I don't like using a dot between two numbers when there's a minus. I don't know, to me this just looks kind of funny. Even if I put it right in the middle, it still looks kind of weird to me. Alright, so we're multiplying them all by -1. So -1, 0, 1, 0, -1. So the normal cosine shape makes kind of like a trough. This is going to be flipped over. It's going to look more like an N shape. Now on the y-axis, you don't have to put labels if you don't want to, because the highest I need to go is 1. The lowest is -1. So I'm going to go by ones. That's what you always go by if you don't put labels. I'll just mark 0. And the x-axis, 0, pi over 2, 2 pi. Get used to writing those labels for today, because every single problem has those labels on the x. Okay, so -1, 0, 1. Let's see, so -1, 0, 1, 0, -1. 0, and -1. And remember, it is part of a wave. So if you think of it like that, you're sketching that part right there. So try to give it a little bit of a curve. There we go. There we go. All right. Any questions on how we got that? Okay. So that pretty much covers the amplitude changes, stretching and compressing up and down. The last thing we're going to look at is shifting up and down. Again, another pretty easy transformation, because shifting up and down is going to affect ones, -1s, and 0s. Okay, what kind of arithmetic is usually involved when you do a shift? Is it multiplication or addition? Addition. Multiplication is a stretch, just like we had with the amplitude change. When you add or subtract a number this way, it's a vertical shift. But we did adding and subtracting yesterday. What's different about this adding and subtracting versus the one we did yesterday? And then there's another example. Yeah.
It's outside of the parentheses.
Right. For this to be a phase shift, you have to put parentheses around the letter and the number. Now it's a phase shift. Because order of operations, you're saying, like if you plug in 5, you're saying do 5 plus 2 and get 7. And now take the sine of 7. Versus when you write it like this, if you plug in 5, you're saying take the sine of 5, and then when you've done that, add 2. Not the same. So the adding and subtracting is outside the parentheses. Which way do you think a plus is going to shift the graph? Don't say vertical. I mean, I know it's vertical. I mean, what specifically vertical? 2 choices. Yeah. Yeah. It's not backwards here. Okay, with the horizontal, you think plus. You're like, oh yeah, plus. Well, number lines go to positive numbers on the right, but plus moves it left. This is not backwards. I don't know any other way to say that. It's not backwards. Because people mix it up on the test. They see a plus here and they move it down too. That's wrong. When you're doing vertical, plus is up, minus is down. So up if you're adding, down if you're subtracting. And again, just think of a point like that, and then imagine shifting that point up. If this point goes from here up to there, what is changing in the coordinate to make it move up or down? Yeah?
The Y.
The y. Okay, so the y value is going to be changing, which means the x's stay the same. Right, so when we shift up or down, copy the x's down from the original table. That's your 0, pi over 2, pi, 3 pi over 2, 2 pi. Now, when we get an amplitude change, all we had to do is take the number that was in front and multiply it by the old y values. This time, it's even easier. All we have to do, instead of multiplication, is addition or subtraction. Take the number that's at the end, either a plus or a minus, and add that value, or subtract it, to the original y values. Don't do the opposite. Don't do the opposite. I don't see anything else though. They used to have a pen where you could put a happy face. I guess they got rid of it. There we go. Don't do the opposite. Okay. All right, so we've got a plus 2. When we find our new y values, are we going to do a plus 2? Or are we going to do a minus 2? We're going to do a plus 2. So let's make our table. Not like that. Okay, so we've got x's and y's. Okay, Ryan just told us what stays the same. Or he told us what changed. It's the y's.
X stays the same.
So x stays the same. So what's going to be my x values? Oh, Abigail, can you tell me my x values?
0, pi over 2, 5, 3 pi over 2.
There's our x values. And let's put the original y values off to the side. Okay, for sine, Tyler, what are my original y values?
0.
Okay.
1. Then 0. And 1.
And what's the last one?
0.
0. And Jackson, what do we do to all of those?
Add 2.
Add 2. Don't do the opposite. Do you do the opposite with a phase shift? Yes, you do. Is this a phase shift? No, it isn't. This is a vertical shift. All right. On to Dominic. What are going to be my new y values?
2, 3, 2, 1, 2.
2, 3, 2, 1, 2. So there's your new y values. Now, for this one, I don't really have to do any scaling because the highest I need to go is 3. So I would just set up your axes like that. You don't even have to label them in this case because we're just going by ones. Okay, and then the x values, remember we said this yesterday, you've got to pick numbers that are equally spaced. And we know that 0, pi over 2, pi, and so on are equally spaced. They're all 90 degrees apart. So let's use those as our labels. 2, 3, 2, 1, 2. So 2, 3, 2, 1, and 2. So it's the sine function shifted up. Okay, now, what would be the amplitude of that? Yeah? 1. Okay, sometimes people say 3. Well, I agree 3 is the highest value, but it's not the amplitude. Amplitude is always imagine drawing a line right in the middle and measure the distance off that center, which in this case is 1. Good. Any questions on that? So that was a sine function shifted up. Let's finish with a cosine going down. So, Keon, I know this one is some type of shift because it has subtraction. How do I know whether it's a phase shift or a vertical shift? Can you tell me more? Because I could write a problem that's a phase shift with parentheses, and it would be a phase shift, not a vertical shift. Right. The number is outside of parentheses. Okay, so the number is not in parentheses with the x. Okay, so Curtis, what stays the same here?
X.
Yep, and my x's are?
0. Pi over 2. Pi will be pi over 2. 2 pi.
Okay, so we got our x's. And Tony, let's put down the original y's off to the side. But you don't have to do the -5 yet. You gotta save a little work for Kim. What are my original y's?
1, 0, -1, 0, 1.
Okay, 1, 0, -1, 0, 1. And what are you going to subtract from?
-5. You subtract 5.
Subtract. So it's -5. And Cameron, what do I get for my new y values?
-4. -5. -6. -5. -1.
There's my table. Any questions on the table? All right, now graphic points. So this time, because all my y values are negative, I set up a piece of graph paper that really just goes negative, right? And I put the grids in there because the further away I get from the axis, the harder it is for me to see where to put the point. You don't have that problem on the homework if you use the sheet I made because the grid's on there for you. All right, so we could do 0, pi over 2, pi, 3 pi over 2, 2 pi. Normally I don't like to put my labels that close to the axis, but I know I'm not drawing up here at all. My sketch is going to be down here. So those are my y's. And now plot points. -4, -5, -6, and then come back up. -4, 5, 6, and come back up. And there's your sketch. As far as a connection with sound on this one, there isn't really anything that I know of to connect this with sound. The phase shift, yes. The amplitude change, yes. And the one we're going to do tomorrow, yes. Not that. Any questions on that? All right, so tonight there is a worksheet on Schoology, just like last night. I think there are 7 questions. Make sure for each, no, actually, maybe there's 6. I can't remember. It's around 5 to 7 questions. Make sure you make the table for each problem, and make sure you show me the sketch. Reminder too, I will be here on Thursday. If there's anything you need to come see me for. And progress reports close this Friday. So I'll be doing your progress reports pretty soon.